So in this one, we're given some equations that we don't have to prove, and we're going to use them. So here are our two equations. So a ball is thrown from level ground, velocity v at an angle of projection of alpha, so it's going up like this, here's v, and we've got the horizontal and vertical displacements. So if we want the Cartesian equation, we make t the subject and so in the x equation, so if I make t the subject, I've got x on v cos alpha. And if I sub that into the y equation, so t is that, I'm going to, of course, run out of room here. Alright, so we've got vt, so let's say t sine alpha minus a half g, and it's t squared cos alpha all squared. Alright, so we just want it to look like the equation they've given us, and you can see that they've put the x on cos squared alpha out the front. So if you think of, if I just do this in another colour, so that x has gone, that cos is gone, but there's another cos there. So we've got to times by cos to get that up there. So the first, better cancel those v's as well. So the first term has the sine alpha, cos alpha there to balance it up, to make that term. All right, and then we've got minus. You can see that I'm still going to have the half, so the half's there, the g's still there, the x is squared, so one of the x's is out the front, so I still need another x inside. I've got a v squared, so put that in, and I've got a cos squared alpha, but that's out the front. So I just get the equation there. So that's just making t the subject of the x equation and subbing it into the y equation. All right, hence, show that the horizontal range, all right, so the hence, so we know that the horizontal range, so if the ball's going like this, so this is, at both these spots, our y is 0. So let's make our y equals 0. When we make our y equals 0, so let's say 0 equals, so two things, so this section could be 0, in which case x equals 0. I might just go like that. So either x equals 0, which is what we'd expect because that's at the beginning, and the other one is this section, if this section is 0. So if that section is going to be 0, then this is going to have to equal this part in order for it to be 0. So let's make x the subject. So now we're going to have 2v squared on g sine alpha cos alpha, and if you think about it, that 2 sine alpha cos alpha is the same as sine 2 alpha. Still got the v squared there, and it's on g, so we get what the horizontal range, so we get this length here. All right, so that's the horizontal range. All right, so let's move over to C. So for part C, we've got v equals 30, and the horizontal, the range is 45. So let's put it in that equation we just got. So the equation was x equals v squared sine 2 alpha, on g. So let's sub that in. So first we're going to sub in 45 for x, right? That was the range. The velocity we're given is 30, so 30 squared sine 2 alpha, and gravity is 10. All right, so I'll times it by 10 there. I'll put 30 squared under here, and we've got sine 2 alpha here. 450 on 900, so we've got a half there. So we know that sine 2 alpha is a half. All right, so 2 alpha, remember, alpha is that angle that it's projected up. So really, alpha is between 0 and 90, so 2 alpha is going to be between 0 and 180. So we know that sine of 30 is a half, and sine of 150 in the second quadrant is also a half. So alpha would be 15 degrees or 75 degrees. So in part 2, so this is being projected over here, here's 45 metres across, and we're placing some sort of wall at 40 metres, and this wall is 2 metres high, so we just want to see if it, hits the wall or if it goes over the wall, depending on this angle of projection. So we've still got v equals 30, now we've got x equals 40, so x equals 40, and we've got these two different angles of projection. So let's look, we want to see if the height is above, at that point is above 2 metres. So we're looking at the y value. So what was our, if we go back to our y equation, whoops. So where's our y equation? Is there y equals x on cos squared alpha, bracket, sine alpha cos alpha minus gx on 2v squared. All right, so remember that one. Let's come over here then. All right, let me just get rid of that then. All right, so we've got y equals, for the first case, so let's go alpha equals 15 degrees. So we're going to have 40 on cos squared 15. We're going to have sine 15, cos 15, minus gravity times 40, and 2 lots of 30 squared. All right, so putting that in the calculator, we get it's approximately equal to 1.19088. So you can see if it's projected at that smaller angle, it's not going to get over the wall when we get to x equals 40. It's going to hit the wall. It's not high enough to get over the 2 metre fence. So let's try 75 then. So again, we're going to get 40 over, this time cos squared 75, sine 75, cos 75, minus 10 40s on 2 30 squareds. All right, so let's try that one. So that's approximately 16.5868. So you can see, yeah, that one reaches over. So this was a small angle. This was like 15 degrees. But if we had a 75 degrees, it would definitely go over that wall and still land at the 45 metre mark. So examine each trajectory, see whether the ball will still travel. So in the second case, it still travels that 45 metres in range.